Pre-calculus. This video is going to walk you through how to do linear factorization over the reals so we get really good at it. Okay. The first thing I want to do is give you more space. So I don't think a half page is going to cut it. So we're going to cross off this problem right here. We're going to use this entire page for the first example. And then we're going to put this example on a clean page at the end of our packet. Okay, so we're going to use this entire page here. All right, make a list of PRZs. Use them to write it in factored form. Okay, so PRZs, here we go. The first thing we do is we write all the factors of 48. So we always start with 1. Okay, can 2 go in? Yes. Can 3 go in? The way I like to do that, 8 plus 4 is 12, which can be divided by 3, so yes, 3 can go in. 4 can go in, not 5, but 6 can go in, not 7, but 8 can go in. Okay, now here's a little trick I like to use. 6 times 8 is 48, so these two factors together make 48. I don't have to try every number until I get to 48 because the other numbers here have their match here. What I mean is 6 times 8 is 48. The next number that's going to work, okay, goes with 4. 4 times 12 makes 48. So 9, 10, and 11 do not work because they don't have a match. 3 times 16 is 48. 2 times 24 and 1 times 48. Okay. Now I got lucky in that there's no leading coefficient here. I could put all these over plus minus 1, but I think that is our PRZ list. All right, let's get going here. I always like to start with 1. I'll try 1. For people that are big writers, okay, please separate your paper in half so you've got some sections. Don't do the problem right in the middle of the paper, okay? I'm going to use this side of the work, this side of the paper. To the 5, to the 4, to the 3, to the 2, to the 1, to the none. Okay, we didn't need any x's. We'll start by dropping it down. 1 times 1 is 1. That adds to 0. 0 added together, negative 4. Negative 4 times 1 is negative 4, adds to 4. Negative 32 plus 4 is negative 28. And that does not make a 0. All right, let's try negative 1. I'm going to copy the same coefficients here so we could test again. Okay. One of the things I want to see on your paper is lots and lots of testing. This is you trying really hard, showing all your work. Okay, how did you figure out which one worked? Through the list of PRZs. 1 times negative 1 is negative 1. That adds to negative 2. Positive 2. Add these together, you get negative 2. Negative times negative makes positive. Now we get 10. Negative 10, that's negative 42. That number did not work as well. Okay, now this did tell me something. Okay, plus and minus 1 did not work. Okay, so I'm going to totally take them out of the running. They didn't work here. They're never going to work. Okay, plus and minus 1 will never work. Okay, so when you get near the end of the problem, you don't need to try it ever again. Okay, well, let's keep going. Let's go on to 2's. Let's try positive 2. 1, negative 4, 8, negative 32, and 48 are the coefficients. Let's begin our test. Drop down the 1. 2 times 1 is 2. Add them together. 2 times 1 is 2. Add them together. Negative times positive is negative 4. I get a 4. 4 times 2 is 8. 8 subtracted from 32 is going to be 24. Ooh, a positive times a negative makes negative 48. Winner, winner. Okay, we found one. Now, what should we do with a number as soon as we find one? As soon as you find one, you should write it in factored form. I'm going to come down here and write my f of x. So the factor that we found is x minus 2. And the quotient that we found is, let's see, this was a fifth, Okay, so this is going to be x to the fourth. 1x to the fourth plus x cubed minus 2x squared plus 4x minus 24. We found it. Okay, but we're nowhere near done factoring. Okay, I can't factor by grouping. It's a fourth degree polynomial. We're going to have to keep testing. Okay, now what number should we test? We should not try plus minus 1. We're done with them. Okay, 2 just worked. Okay, but what I'm going to do is try it again. All right, you're going to try it again. It might work again. I can't cross positive 2 off. I'm not done with him. He worked once. He might work again. Okay, so let's try 2 again. But now we're going to work with these numbers right here. This is the part that I'm trying to split up. What I'm trying to do is split him up into x to the first and x to the third. Okay, so what I'm trying to do here is split him up into x and x cubed. Okay, so let's take these coefficients. You can get them right here from the bottom again. You don't want to start with the coefficients from the original problem. That would be like starting all over again. That would be like doing this step all over again. You start with the fifth, you're going to find the fourth again. I want to take the fourth and turn it into a cubic and a linear. All right, let's try. Drop it down 1. 2 times 1 is 2. Add together to make a 3. 2 times 3 is 6. Add these together, we get 4. 4 times 2 is 8. Add this together, we get 12. Oh, look at this. It worked again. It worked again. So my little note to you, okay? We must use the 0. We must use the 0, the x-intercept, the number, until it's exhausted. That doesn't mean tired, okay? Until it's totally used up and exhausted. That worked again, okay? So I'm going to write this all down here in red. I just found x minus 2, and this must be x to the third, right? It was a fourth, so we have 1x cubed plus 3x squared plus 4x plus 12, okay? Now what I really want people to do right here, okay, this is not good. It's not complete. We have to write the factor that we found before. We have to write our equal sign and our f of x. Let's just do a quick check, okay? When this problem started, he was a 5th degree polynomial, okay? When I wrote f of x here, is he a 5th degree on this line? Yes. 1 and a 4. Is he a 5th degree polynomial here? Yes. 1, 2, 3, 4, 5. Every time I write f of x, he better be a 5th degree polynomial. He can never turn into a 4th degree. Okay, are we done? No, we're certainly not done. Okay, we still have to work on this. All right, is there any way I can get this done, or do I have to keep testing? Does this factor? It's got 4 terms. Okay, so sometimes when it's got 4, I stop testing. Okay, I really don't want to go through this whole list. Look how long this list of PRCs is. Let's see if we can get this thing factored by grouping. Okay, so let's write down what we have so far. We don't want to lose anything. We have the x minus 2. We have this x minus 2. And what I'm going to do now is use some big brackets to get this cubic factor. I'm going to take 2 x's out of the first 2 terms. And that leaves me with x plus 3. Is there any way to take something out of these next 2 so that I get duplicates? You have to write plus minus number. I'm going to take out a positive 4, and that gives me x plus 3. Look at that, it worked. Okay, so f of x equals, we found x plus 2 the first time. We found x minus 2 the second time. Okay, I'm noticing I see duplicates, x plus 3, and then our leftovers are x squared plus 4. Okay, can this factor any further? Okay, the answer is no. If it was a difference of squares, yes. Okay, but we call this an irreducible an irreducible quadratic. Okay, I really wanted to keep going until I found all 5, but this one does not factor. Okay, so this is as much as I can factor it over the reals. Okay, let's go to the back of your packet. Let's go to page 84. It's a big blank page, and we're going to do that problem that we crossed off way back here. Okay, so here's the problem. 2x to the 4th minus 20x cubed minus 2x squared plus 5x minus 1. We're going to get this factored over the reals, so we're going to start with some PRZs. Okay, so the PRZs. Factors of 1, oh, that's easy, plus minus 1. Oh no, look at this. Divided by the factors of 24. All right, what goes into 24? 1 and 2 and 3 and 4. Not 5, but 6 does. Oh, 4 times 6 is 24. Okay, I've hit the halfway point. When you've hit the halfway point, you just have to bring it on home, okay? 3 times what? 3 times 8 makes 24. 2 times 12, and 1 times 24. When you get that halfway point, you can just use the first half. That'll speed things up. Now, what is every possible combination of these PRZs? Well, the first one is plus minus 1. But every other one is going to be a denominator. We have 1/2, we have 1/3, comma 1/4, comma 1/6, 1/8, 1/12, and 1/24. That's a lot of fractions to test. I'll start with the ones and hope I don't have to get to the fractions. Okay, let's go ahead and separate our paper down the middle. Okay, for people that are big writers, we're going to use half the paper here to test. I'm going to start with 1. Okay, try to write tiny because you might have to test a whole bunch, right? Not just one problem of testing, lots and lots of problems. 24 to the 4th power, negative 20, negative 2, positive 5. Oh, no oxes. That's good. Okay. Drop down 24. Okay, I'm testing 1. 1 times 24. Subtract 20, we have 4. 4 times 1 is 4. Subtract 2, 2. We have 2, 7. Oh, that did not work. Okay, sorry, 1. Let's try negative 1. Maybe we'll get lucky with the negatives. I'm going to copy the same coefficients. Okay, if I go too fast, pause the video and you can think slowly on your own. Drop down 24. Negative 1 times 24 is negative 24. And this adds to negative 44. Negative times negative is positive, so we have 42. Negative 42 minus 5. There's no way this is going to work. Okay, it did not work. So what I do know is I can totally cross off plus and minus 1. Didn't work now, it's never going to work. All right, let's go to 1/2. 1/2. 24, negative 20, negative 2, 5, negative 1. I'm feeling good about 1/2. Okay, some people get scared of the fractions. 1/2 is the same as divide by 2. Okay, so you could say half or you could say divide by 2, whatever makes it easy for your brain. Okay, so I dropped down 24. You could say half of 24, or we could say what's 24 divided by 2, and the answer is 12. Add this together, negative 8. Okay, what's half of 8? That's a 4. Okay, but that's going to be a negative 4. And we have negative 6. What's half of negative 6? Negative 3. 5 minus 3 is 2. Half of 2 is 1. We found it. We found it. As soon as you find one that works, okay, we're going to come over here on this side, and we're going to write the new f of x. F of x was a 4th. Okay, so what we should have is a little guy and a big guy. Okay, the little guy, the factor that we found, is x minus 1/2. This was a 5th power, so now my answer is a quartic. 24x to the 4th minus 8x cubed Oh, what am I saying? This was a fourth. Oh, this was a fourth. My answer is going to be a third. I was going to say I didn't have enough terms there. That's a second degree power minus 6x plus 2. I apologize. That's a 3 and that's a 1 because our problem was a fourth. Okay, good catch. All right, now what are we supposed to do when we get a fraction? Okay. Whenever you get a fraction, when a fraction is a 0, okay, what are we going to do? Okay, we want to clean this up. Over here, all of these numbers are even. Okay, so we're going to divide out a 2. We're going to divide out a 2. All right, so let's see. If I take a 2 out, where am I going to put that 2? Oh, I know. We're going to multiply it into this factor. Okay, multiply the 2 in. And that always happens. We're going to divide out a 2 from this cubic, and we're going to give it to this factor to clean it up a little bit. So if I distribute here, multiply 2, that's going to be 2x minus 1. If I divide a 2 out of him, he's 12x cubed minus 8x squared minus 3x plus 1. Okay, is that good? Let's see. What's 2 times 12? My problem was 24x to the 4th, and that works. Okay, every line, f of x, needs to be a quartic that has a leading coefficient of 24. Okay, every time you get a fraction, okay, when a fraction is a 0, you're going to factor out the number from your quotient and put it into your divisor. Okay, I do not think this problem is done, okay, but I'm really thinking that maybe we can continue on with some factor by grouping. Okay, factor by grouping. I don't really want to keep testing more fractions, okay, but I think maybe we can get this factor. Okay, so what I want you to do is use some big brackets. Just this entire quantity gets in there. From the first 2, let's take out 4x squared. And that's going to leave us with 3x minus 1. Oh, I think I can make duplicates. You have to say plus minus number here. I'm going to take out a negative 1, leaving us with 3x minus 1. Okay, if you have duplicates, that means that it's working. It's working, okay? F of x equals, let's write down this factor. We can't ever lose that one, okay? The thing that I see duplicate, I'm going to write down that factor, okay? And then the leftovers are 4x squared minus 1. Okay, are we done? No, we're not done. We have to factor further. Okay, how does that factor? Well, difference of squares, right? Difference of squares. So we're going to have f of x equals 2x minus 1, 3x minus 1. Okay, difference of squares here. 2x minus 1, 2x plus 1. Okay, so this right here is what we call factored form. Factored form. Okay, this is factored form. Up at the beginning, okay, what do we call something like this? This is called a polynomial. A polynomial is multiplied out and has many terms. F of x is a 24x to the 4th. He's a quartic. Okay, down here, different form, he should still be a quartic. 1, 2, 3, 4th degree. 2 times 3 is 6, times 2 is 12, times 2 he's still y equals 24x to the 4th. Okay, if the problem said state the zeros, okay, the first one is 1/2. We have another one at 1/3. We have another one at 1/2. And we have another one at negative 1/2. Okay, all of these should be up here in our list of PRZs. I notice 1/2 would have worked again. it would have worked again. So you have to keep using them until he's exhausted. Okay, great. Let's go back to our notes. Let's go back to our notes because we have one more example. Okay, and there's a lot of paper here, so we could go back and use this space. Make a list of PRZs and factor. Okay, PRZs for this guy. We've got plus minus 1, 2, 4. Leading coefficient's 4, so we have to do every possible combination of 1, 2, and 4. So let's make that list, okay? Let's divide everybody by a 1. And that makes 1, 2, 4. Let's divide everybody by 2. That's going to make 1/2. 2 divided by 2 is 1. 4 divided by 2 is 2. I already got those. Okay, let's divide by 4. 1 divided by 4 is 1/4. 2 divided by 4 is 1/2. I already have that. 4 divided by 4 is 1. So here's the list of numbers that might possibly work. Might possibly work. Okay, let's go ahead and split our paper down the middle. I like to keep this side for the testing and then this side for the writing the factored form. Okay, I'm going to start with 1. I always hope that 1 works. All right, we've got power of 4. Oh, we need an ox. Power of 3. Power of 2. Power of 1. Power of 9. Okay, here we go. Drop down the 4. 4, 4, 4 plus 15 is 19. 19 plus nothing is 19, and it did not work. Let's try -1. Okay, does -1 work? Let's see. 4 negative times negative makes positive. 19 times -1 negative. Nope. Okay, well at least I found out something, okay? Plus minus 1 does not work. It's not going to work now. It's never going to work. I can just totally cross it off the list. All right, so I guess we'll try 2. Let's go for a 2. Does 2 work? 4, 0, 15, 0, -4. 4 times 2 is 8. 8 times 2 is 16. Ugh. 31 times 2. This is not working. Nope. 2 does not work. Let's try -2. Okay. I hope by now you're realizing you're going to have to show lots of work. You're going to have lots of testing that doesn't work until you find one that does work. Okay? This is what I am expecting to see. It's how it's done. There's no shortcuts, guys. 4 times -2 is -8. Add it together. Negative to something is positive. 31. -62. This is not working. Okay, sorry, 2. Not working. Oh, what is going on here? Should we try a fraction? I feel like we're going to keep trying the good numbers and we're going to have to get, let's just try 1/2. I'm feeling like 1/2 might be lucky. Okay, usually I try to be systematic, but I think I see something here. 4, 0, 15, 0, -4. Drop down the 4. Half of 4 is 2. Half of 2 makes 1. 15 and 1 add together. What's half of 16? 8. Half of 8 makes 4. I knew it. I knew it. We found one that works. As soon as you find one that works, let's come over here in this column and let's write f of x in factored form. So when you get 1/2 as the 0, we're going to write x minus 1/2. This problem started off as a 4th, so my answer must be a 3rd. 4x cubed plus 2x squared plus 16x plus 8. Okay, I just talked to you about the last problem. When you have a fraction that works, remember what we have to do? We have to clean it up. He's dying to get multiplied by 2. We want to get that fraction out of there. all of these numbers here are even. I'm going to take out a 2, 2x cubed plus 1x squared plus 8x plus 4. I'm dividing out a 2, and where am I going to distribute that to? Into this factor. So it's 2x minus 1. Nice. Okay, can we do factor by grouping? 2 and 1. Oh, maybe we can do factor by grouping. All right, we should always try to stop, okay, and see if we can factor. I'm going to put some brackets here. Brackets. From the first two, let's see, from the first group, what can I take out? I can't take out a number, but I can factor out x squared, and that would give me 2x plus 1. From the second group, I'll take out plus 4, and that would give me 2x plus 1. Perfect! All right, so f of x is equal to 2x minus 1. Just drop that down. Okay. The duplicates here that I see are 2x plus 1, and then right there, x squared plus 4. Can I factor this any further? No, because remember what that's called? Irreducible quadratic. So I've got this factored as much as I could. Hey, wait a minute. Let's go up here for just a second. Could I have just simply factored this problem to start with? 4x to the 4th plus 15x, but this is actually a trinomial. This is actually a trinomial. Some people are good at factoring. Some people make an MA table. If I did, let's see, 4x squared times x squared. And how do you make a 4? I can't put 2 here because I can't take a 2 out. I think this has to be a 1 and a 4. If I put a minus here and a plus here, does this work? 4x to the 4th. My outers would be 16x squared, and the inners would be minus 1x squared. That would make 15x squared. And this is a difference of squares right here. So I could have just factored this. 2x minus 1, 2x plus 1. Here's that irreducible quadratic again. Oh my goodness, look at this. 3 lines of work and we could have had it done. The moral of the story is always look to factor first. Okay, and really we should say factor first, factor in the middle, factor at the end. Always look to factor. At some point you might be able to just do factor by grouping, or I could have skipped all this work and just done factoring. Good to know for next time.